All right, so let me show you what I do to easily find exact values for trig functions. So instead of memorizing the unit circle or um, memorizing the values for 30, 60, 90, 45, I just keep these few things in mind. And so when you're sitting down to solve these, this is what I would jot down on a separate piece of paper and keep handy. So I always think about unit circle for exact values of your quadrantal angles, meaning 0, pi over 2, pi, 3 pi over 2, 2 pi. We could keep going around and around. And then those associated points. And then remember that, each ordered pair is cosine theta, sine theta, and then it's helpful to think about the other 6 functions in terms of sine and cosine. That tangent theta is the same as sine theta over cosine theta. So cotangent theta is cosine theta over sine theta. So this is what that would be the same as y over x. This is the same then as x over y. Same thing with the reciprocal functions, that cosecant theta is the same as 1 over sine theta. Secant theta is the same as 1 over cosine theta. So this would give us, again, in terms of that x, y ordered pair, this is the same as 1 over y. This is the same as 1 over x. And so again, that really is helpful when you're thinking of exact values for those angles, meaning if I wanted to know what is tangent of pi. So then I can look at the ordered pair associated with that angle. So this would be sine over cosine, or y over x, which is 0 over -1, or 0. Okay, it's also very helpful to know your radians in degrees for those special angles that we've talked about. So like that pi over 4 is the same as 45 degrees. That pi over 6 is the same as 30 degrees. And that pi over 3 is the same as 60 degrees. And again, they're easy to do the work to convert them, but it's really helpful if you can just remember those off the top of your head. So then it's helpful to keep in mind the special triangles that we've talked about for exact values of trig functions of those 3 special angles. So your 30-60 triangle and the relationship, the ratio of the sides, which is 1, 2, square root 3. So again, if you're asked then to find, what is cosine of pi over 3? Well, if you have this triangle in front of you, okay, I know pi over 3 is 60 degrees, and cosine is the adjacent side over the hypotenuse. So then I can quickly and easily see that cosine of pi over 3 is 1/2. Same thing, keeping that 45, 45, 90 triangle in mind. Or pi over 4, pi over 4. And that the ratio of sides is 1, 1, square root 2. Again, so you can quickly see, okay, if I'm looking for tan of pi over 4, and then I have opposite over adjacent, so I know that that's 1. So it's also sometimes a lot of people to remember the relationship of adjacent over hypotenuse, or it's helpful to think of that SOHCAHTOA. That's where that comes in. Again, that we have sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. The last thing I keep in mind is, which functions are positive in which quadrants. And for that, some people remember all students take calculus for that ASTC. For some reason, I always just think of the word cast starting in quadrant 4, C-A-S-T. Jotting that down on that little XY plane where you draw your unit circle, again, reminds you that, okay, all angles in quadrant 4, cosine of that angle is positive. Everything's positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. So remembering that is helpful. So again, I keep this handy when I'm solving equations